SwayamPrabha. Digital India. Educated India.
Good morning students, welcome to the NPTEL online course on structural systems in architecture. Today we will discuss the lecture 3 on module 1. The lecture 3 will be on the moment couples and static equilibrium. So, in the past lecture we have seen that the force system, and also in the last the slides of the force system we have seen there are the two important parameters in the structural loading, that is called moment and the couples. So, today we will in our concept we will initially discuss about that moment and couple a bit, and then we will again go to the force system and we will see the how a resultant of the force is can be obtained, how a force system in the force system resolving of the force system can be done, and also what are the equilibrium condition for the force system. These three, resultant, resolving and the equilibrium of the force system are very important for the statics point of view, and most of the times in our building, in our architecture, in our structural engineering, we will go with this system of forces, and with sometimes we find out the resultant, sometimes we will find out the what is the equilibrium conditions and all. So, the learning objective for this lecture, the lecture number 3 will be, we will first try to conceptualize the moment and the couple, and then we will outline the resultant and the resolving of the force system. So, we will do the some of the small computational or the mathematical things, and those are already you know by virtue of your class 12 physics. And finally, we will go to the equilibrium condition for the force system, which actually applicable for the static equilibrium conditions also. Now, what are the moment? What is moment? Moment and the couple are described as the effect and the cause. The cause is the moment and the effect is the couple of a force system of any kind of rigid body. So, it is a rigid body mechanics when a force is applied to a particular point, and then from a other point, when the other point is separated by a certain distance, we can find out the what is how much is the turning effect of that particular force, how much is going to be turned. Turn means it is how much will be the rotational effect of the particular force because of that particular distance separation of certain point. So, the amount of moment is directly proportional to the magnitude of the force and the distance between the force and the particular point, which I am going to mention for different purpose and different systems or so. And this is as you understand from the second line or the third line is that the unit of the moment will be the Newton meter, because Newton is the unit of force and the meter is the distance. So, it is just multiplication of the Newton meter, and both are directly proportional to the of that. In physical sense, the moment is described as a torque. Now, see in this particular figure, there is a point P, which is suppose this is the point P, and there is a force line of action of the force is something like this F, and the perpendicular distance is D. If this is the scenario, then I can say the moment is the force multiplied by the distance also. Okay, so, the force is the force and the line of action of the force I have to identify, and I have to see the what is the perpendicular distance from the force. So, suppose a particular point force is something like this and a point is something like this. So, I have to take the perpendicular distance, not the any arbitrary distance. There are many distances possible from the from that point to the force, but I have to take the perpendicular distance from the force to the point. So, that is one of the very important thing. So, next is the couple. Couple is a system of two forces when they are equal in magnitude, but opposite in direction. So, something like this, when two forces are applied in a particular rigid body. So, one force is downward and another force is upward, but see both the forces are same and they are having some separation distance d1 plus d2. So, that is the separation distance between them. So, I am going to find out what is the suppose the couple at this particular point. So, I have the point and I have two distances and two perpendicular distances from the force. So, I have two moment generated, the m1 for the first or the left hand side force F into d1 and the m2 is the generated moment due to the second force, the right hand side force F into d2. So, now if I now both the moment are in the same direction, anti-clockwise direction. See, this is also anti-clockwise direction. So, both the moments are of anti-clockwise direction. So, something like this is also something. So, we can arithmetically add both of them. So, total moment will be the m1 plus m2, and now if I finally do all the addition f1 and d1 multiplied plus f2 and d2 multiplied. So, finally, it gives me the f into d. So, the moment of a couple is the two forces which is opposite in direction and the equal in magnitude, is magnitude of the force, that is F, and the perpendicular distance between the force. So, that means this is the d. Okay, so, that gives me the again formula generated to find out the couple. Now, what are the difference between the couple? Already I have discussed that the moment is the force that measure the turning effort or the rotational effort by a force from a given point, about a given point, and couple are the two equal and opposite forces acting in a particular rigid body, parallel lines to each other. Non-parallel forces may not give you a particular couple, it may have to again resolve and find out the couples also. So, this is the difference between the moment and the couple. So, let us take example. So, I have a bar and this bar is hinged or pinned at this particular point. So, this bar can rotate, the bar can rotate is under any kind of a force. The length of the bar is 3 meter and it is having an inclination with the horizontal as 30 degrees. So, I put a force, I put a straight horizontal force F as 20 Newton. So, if I put a force 20 Newton, so as I know that I have to find out the distance from the force to this particular point as a perpendicular distance. So, perpendicular distance is almost this distance. So, and this distance, and so this distance is 3 centimeter, but what is the component of this particular force, that I have to find out. So, this is the sum of the component I have to find out. So, if this is the force, so I can say this angle is also going to be my 30 degree. So, suppose if I now take the red color as the force. So, I have to find out what is the force, and I have already found out this thing. So, this is the force and this is the angle 30 degrees. So, this force is 17.32 as it is the cos component of the 20 and this is the sin component of the 20. So, this is 10. So, out of that, so I may say that this is 17.32 and this is going to be your 10. So, next is, see, this force I have placed over here, and then you see then these two forces are placed over here, but the force 17.32 this is acting now along with the axis. So, this will not create any kind of moment because the perpendicular distance from this point to the force is 0. So, F into d, the d is 0. So, the moment is equal to 0, but this 10 is definitely having a distance of 3 meter or so. So, the final moment will be your 10 into 3. So, 30 Newton per meter. So, even though it is a 20 and it is acting here, it is not going to be 20 into 3, it will be 10 into 3, because the perpendicular component of the force is 10 and the other component is going to be through the axis. So, it will not going to be considered. Now, next let us go to the next the agenda of this today's lecture is the resultant of the force, how the resultant of the force can be computed. The first we take the coplanar forces. So, suppose a body is under a force of P and Q, which is 3 and 2 kilo Newton respectively, both are acting in the same direction. So, this will be just arithmetically added as 5, resultant will be 5. Similarly, if the force or P and Q are opposite in direction, one in the 3 Newton in the right hand side and another is the 2. So, this 2 will be now negative minus 2, and the resultant force will be in the right hand side direction only 1 Newton. And very similarly, if I have the forces in the vertical directions also, say I can have the downward resultant force as 3, because 5 minus 2 is equal to 3. So, those are the resultant force computation for the coplanar forces, which is already you know. Now, the coplanar forces, when it is the concurrent forces are means are when the forces are of from a certain point and there are forces of different directions, maybe of this is also maybe another force or something like this. So, how to calculate the forces or the resultant forces of that. So, the P and Q are now suppose inclined at theta degree, and I want to find out the what is the resultant forces. So, suppose this is a yellow color ball and somebody is pulling at a force higher force P in the horizontal direction, and another person is pulling that particular same ball in a Q force, which is a smaller force with respect to P, and it is in theta direction with respect to the P. So, we know that the influence of P will be much higher with compared to influence of Q, because the amount or the magnitude of the P is higher. So, it will actually go in this particular line. So, because it will be near to the P, because the influence of P will be very higher. So, with respect to Q. And finally, we can have a parallelogram created by the two parallel lines of P and Q, and we can say that the resultant forces will be going to be the R, which is the chord or the diagonal of that particular parallelogram. So, now the formula, this is this particular if you have this R and this is having a theta. So, it is very general formula that R is equal to under root P square plus Q square plus 2 P Q cos theta. We can know that very formula very well, and suppose if I put some values also, this P is 12, Q is 20 and the theta is 60 degree. So, I can just put those values in the formula and I can find out the resultant value is almost about R is under root 784, or the total value actual value is 28 Newton. So, and also I can find out what is the angle of that also, also we can find out by some formulas also. Now, if these two forces are perpendicular, so the angle between the suppose angle between the P and Q is suppose 90 degree, this is 90 degree. So, the theta becomes 90 degree. So, here the cos theta I will put 90 degree, cos 90 is equal to your 0. So, that total things vanishes. So, it will be P square plus Q square, which is the from the geometry you know that is the hypotenuse of a triangle whose base and the heights are P and Q. So, very similarly we can compute for a force like 8 and 6 Newton, which are in the perpendicular direction, the resultant will be 10 Newton. So, this is for the collinear forces, and this collinear forces also can be thought of through a law of triangle. So, suppose the earlier example, if I take P and Q with an angle of theta, the Q can be placed like this and the P can be shifted. P can be shifted from this point to this point. So, this P can be shifted with the same inclination will remain as same, just shifting is there, and then we can close this triangle by the other side of the triangle, and we can find out the resultant. But when you close it, so see, this is going like this, this is going like this, but this should not be a closed, so this will be the opposite side direction. So that we have to see that that closing triangle will be the finally will be the opposite way around to find out, give the proper direction of the resultant force also. So for the perpendicularity also we can find out similar way the resultant. So the resultant force is the reverse direction closing triangle side. So now the resultant force for the coplanar, the parallel forces. The parallel forces are those, the 2 P and Q are the parallel force on a rigid body. So there must be a the resultant. The resultant is that opposite. I mean, I'm showing at this as opposite to the resultant force as equilibrium kind of a condition. So the R will be such a way placed that it will be actually valid for valid this equation. The P into D1, that means this P into this D1 must be equal to the Q into this D2. So from that, if I know the distance between them and if I know the P and Q value, I can find out where will be the resultant force, or these things will be located, and what will be the magnitude will be definitely P plus Q, because both are adding are the same in the same direction. So suppose this is another, if I put this formula like 4 and 10 as 2 forces, Newton as downward direction having a separation of 140 centimeter. So this gives me the resultant force is 14, because this 10 plus 4 is 14, and by this equation I have put it over here, that is the 4 into D1. Why 4? This P, this is my P, is D1, I do not know the D1, the location, and the 10 is this Q into 140 minus D1, this distance, if this is the D1, this is 140 minus D1, this distance. So I will now multiply and then find out that D1 is equal to 100 centimeter or so. So that way also I can find out the location of the resultant force of the parallel forces systems also. Now next let us go to the resolving of the force system. So suppose in a body, there is this yellow color, there is a ball or a body, the force P is acted at an angle of theta. So and I have to make the resolve this force in the x and the y axis. It is very easy, and we have to just drop the perpendicular from the end point, and I can find out these two are the cos component of the P and this is the sin component of the P, because this is your theta. So this will be the cos component towards theta and the other side will be the sin component. So if this is 20 and this is 60, so I can say this will be the 10 and this will be the 17.32 as the I have written over here, because the cos component is 10, because it is cos 60 is 0.5 and sin 60 is 0.66866. So again we can see that if I have these two, so the resultant force which is here, which will be your under root P square plus Q square, which is this two. If I square it and then under root it, I will again find that it is the actual force is you are going to be 20. So it proves that the resultant force from that point of view we can find out we can resolve the force, and then also we can find out the resultant force from the resolved forces. So now let us suppose I have 3 such forces which is have 15, 45 and 60 degree inclination with the horizontal axis and 10, 12 and 8 kilonewton in nature. So I have noted down the forces 10, 12 and 8 and the angles with the x axis, and P cos theta and the P sin theta is also found out. So if I take the 10 alone, so this is the 9.7 which is this, and 2.6 which is close to 2.7, actually it is 2.7, and similarly your another force is 12, so this 8.6 is this, and 8.5, sorry, 8.5 is this, and this is also 8.5 both, and the final is the 8, which is downward 60 degree with x axis, gives 4 as this one, and this is the 6.9. So, I have found out by some calculations, and now these 3 red color forces is resolved into 6 green color forces, which are those green color forces are in the perpendicular direction, x and y direction. So, I can now, instead of this, I can say that this is very equal to this. And now I have in x direction, how much are the forces? 9.7, and these two are negative force because it is opposite in direction. So, minus 8.5 and 4. So, finally, I got 2.8. Similarly, the y direction forces, it is 8.5 and 2.7 positive y direction force and minus 6.9. So, plus 4.3 is this. So, I can find out the resultant by virtue of the r equal to under root p square plus q square. So, resultant force I can find out is this. So, I can say finally that, and also I can find out the angle theta also by virtue of the this trigonometry, and so the alpha goes like 57 degrees. So, if it is 57 degree, this is 180 minus 57 degrees, so 123 degrees. So, I can say this force system is nothing but a resultant force is like this, which is your 5.13, and this inclination is 123 degree. So, through the resultant again I can come back to the final the resolving and the resultant of the force. Now, let us discuss about the equilibrium of the forces. So, let take this green ball, and suppose this green ball is equilibrium under the 5 forces. So, what I do, I can break those 5 forces in the x and y direction, and then there are forces in x and y direction. So, as we did in the earlier. So, now I can say this force, this ball is under those x and y direction forces, and how we will do that? Because we can do that by, if I know the inclination and the amount of the force, I can do by cos component or the sin component. So, those x direction forces, total sum of the x direction forces must be equal to 0, otherwise it will move in any positive or negative x axis. Similarly, the y directional forces, sum of the y direction forces also, sum of the y forces also has to be 0, otherwise it will move in the either up or down direction. So, I can say that the sum of f x, that is the force in x direction, must be equal to 0, and the sum of f y, that is the y direction forces or the vertical direction forces, must be equal to 0 to maintain the equilibrium of this green ball. So, these two are the very basic consideration for the equilibrium. So, I have taken again example. So, this particular 200 Newton load is applied in a particular body in a rope. So, I want to find out this tension in the wire and the rope T1 and T2. So, I know the inclination. So, what I will do is that I know this is unknown to me T1. So, I have resolved this T1 sin theta and T1 cos theta. Similarly, that is the other rope, other side, right hand side is T2, is the tension on the in the rope, and that one also is resolved into cos theta and sin theta component. Now, what I have is that I have only the horizontal and the vertical component of the load. So, if I equate the x axis, so I have x axis only this and this. So, these two are equal, must be equal, otherwise that particular body will move in the x axis direction. So, I get a relation, first relation. Similarly, if I take this y axis, the equation of the equilibrium in the y axis, this must be equal to 0. So, this plus this plus this must be equal to 200. So, from this two equation I have, and I have two unknown also T1 and T2, and I can solve them by virtue of the linear equation. I can find out the what are the tension in the T1 and T2. So, equilibrium of the forces also have a third component, in the moment also it has should be equilibrium. So, I have shown here a body, rigid body, which is under a P and P2 force at a distance d1 and d2 from a particular pin. So, Now the moment at this particular point, as I know, the P1 into perpendicular distance is d1, so it is P1 into d1. Similarly, at this particular point, due to the load P2 is the moment at right hand side Mr equal to P2 into d2. So suppose if I have the 2 kg and 2 kg load in the at this particular distance of 3 and 5 meter from this particular internal hinge. So the moment is 2 into 3 is 6 in the left hand side and 5 into 2 10 in the right hand side. So definitely this bar will going to rotate. So it is not equilibrium condition. Similarly, if I have 2 kg and 1 kg and 5 meter and 5 meter, and then I have the 10, 5 into 2 10 and 5 into 5, sorry, 5 into 1 is 5 kg meter is the moment. So it is also going to rotate in other way around. So because of the distance and the load, this particular bar will swing. So if I have this 2 and 5, so I may say now the clockwise and the anti-clockwise moment are something like this. One side it is 10, 2 into 5, and another side is 5 into 5, 25. So it will move like this. But if I put 9 and 1 kilonewton load at distance 2 meter and 3 meter respectively, then I will get this green color anti-clockwise moment and the clockwise moment as 9 into 2 18 and 1 into 3, that is 3. Now if I add up all the anti-clockwise moment, that is 10 and the 18, that is 28, and the clockwise moment as the 25 and the 3 is your 28. So both will be now under will be equilibrium. So in the case of that, this bar will not going to move. So in the equilibrium conditions also, I may say that the sum of all the moments must be equal to 0. Then it will not going to rotate under any kind of motion. So finally what we found is that we found there are 3 equations of the moment. One is the equation of the equilibrium, one is the fx, summation fx equal to 0, summation fy equal to 0, and summation moment equal to 0. So there are 2 such points, and now I can find out what are the forces or so. So I take the moment about fy equal to 0, so the p equal to p1 plus p2, so this is this plus this. And also if I take the moment about A, so I have this force R at a distance of d1, so R d1, and P2 into at a distance of D, so PD, P2 into D, or so this 2 has to be equal to 0. Or if I take the moment about B, so the equation changes like R into D2 in this case and P1 into D into this case. So or if I take a moment about C also, the P1 into D1 must be equal to P2 into D2. So that way also I can find out the forces and all the moments also. Suppose in a body the forces are acting like this in a different orientation. So as I know, I can resolve the forces, so I can resolve this force P as Px and Py, and similarly I can resolve the forces Qx and Qy like this. Now all the forces are in the either in x direction or the y direction. Y direction forces are the Py, Qy and S, and that gives me some R value, the resultant value in R y direction. And the x axis direction, the forces are Px, Qx and no S is there. So this is the Rx will be found out, and then finally I can find out the what is the reaction or the resultant reaction between them, and with this formula I can also find out the what will be the angle theta for that. So for this particular lecture I have taken the reference as this 3 reference like earlier one, and at the conclusion we can say that the moment and the couple are the 2 product of the force system associated with the distance and condition of the support. Why condition of the support? Because you need a pin support in between, because if you want to finalize, figure out the moment or so. The resultant of the force and the resolving of the 2 forces into 2 specific orthogonal directions is required, is essentially required, because a lot of forces are in different angle or different way it will act upon. So you have to resolve into orthogonal direction. The 3 equation of the static equilibrium holds key for the analysis of the structure, because otherwise we cannot have any kind of the virtually equation is required, a boundary equation is required to find out the what will be the total nature of the forces or so. So based on that, my next lecture number 4 will be structural supports and the reaction. But before we end today, I have some homework for you. So, the first I have 3 homework for you for this. So, this is very easy. You have to find out the resultant force for this force system. The second one is that a particular inclined body is under a force 5 kilonewton, red color force, and this is the 60 degree. So, definitely it will going to move, and if it is going to move, so what should be the value of Q, force Q at B, which is 30 centimeter from O, that will going to give you equilibrium. And the last one is that there is again a mass, 100 Newton mass is hanging by 2 ropes of AC and AB, and AB rope is 45 degree inclined, but AC rope has these 5 inclinations. Suppose it is 0 degree, 30, 45, 60 or 90 degree. So, what will be the change in the tension in the AB and AC because of the change of this orientation of the AC only. AB I am not going to change, AB will always going to be 45 degree. So, what will be the force nature, and try to draw a graph for the changing force A to C by the virtue of the angle. So, suppose you may take a graph and this is the angle theta. So, various angle, and you can plot the what is the changing pattern of the forces because of the this changing of angles. And thank you very much.